hundreds of models that we can use. The idea is that you understood a little bit about SAGA, a little bit about geomorphometry, get the idea of how powerful this can be. And what I'm going to show you, we're going to try to do also in your computers, because you should have QGIS installed, but I'm not sure, 100% sure if this is going to work. But we're going to try it not, you just look at what I would do. But what I'm going to do is just try to do the same things that I have been doing in SAGA, using SAGA actually, but not from SAGA, but from outside, from QGIS. That probably you're familiar with that. It's a GIS that is much more powerful than SAGA. You can do many more things you can do in SAGA, but processing, you can use SAGA for doing the processing. So we're going to see how to do this, exactly the same thing, but we're going to be able to automate things and do things better. So the interesting thing about SAGA is that it's very powerful, it goes fast, it has a lot of different processing algorithms, but there are things that are not so good. Like how we look at the interface is not very good, it's not very comfortable or practical to just use all this separated views and all that. It's much better to do that with QGIS. Symbology is really, really good. The symbology in SAGA is not very good. So what I'm going to do is go to QGIS and try to do the same, but better, right? So this is basically the idea. You try to follow me, and let's see if it works, because I'm not sure if that's everything configured in your system. SAGA should be. SAGA is configured in your system, but I'm not sure if QG is not the link between QGIS and SAGA is configured. So I'm going to close actually this. Okay, so you see when I close SAGA, I say, hey, all these things are temporary. You want to keep any of them, Bye-bye. And now I open QGIS, which you should have in your system somehow. You can find it. Right, well, this is a project that I'm not going to use. And then you can open the same layer, like layer, add raster layer, and you just select the same thing, the same layer you had. You see here that it's a little bit twisted. That's because it's reprojecting. That's one of the things that QGIS has that SAGA doesn't have. It handles the different projections. So you see, I'm using EPSG4326 in here, and this is not the native projection of the data, so it appears twisted, but it's not a problem, don't worry. Okay. So basically, I'm going to try to do the same things as I did in here, and all the analysis in QGIS is done through something called SAGA, which is this, right? You open your analysis, you should have there something called analysis, and then you have this extended toolbox, which is basically a list of all the algorithms that you have in SAGA, plus many more algorithms, plus orders. Okay. Sextant. Right.
Здесь нет, что ли?
What's happened?
Ну что, там есть сексtant?
Я не
Okay, so you don't have sextant in your computer, right? Then I guess you're not going to use the whole. You don't have it.
Значит, конец.
Well, just idea.
Ой, слушайте, это плохо, потому что это не только секстант, это SAGA устанавливать, это лишь Ну да, но это не только секстант установить, это надо еще SAGA будет установить, это...
У нас не надо.
Не надо?
Не надо. Я смотрю.
Либо установить другой кугис.
Православный.
Мы можем дальше зайти?
Да? Жень, забей, просто в демо-режиме можно показать. Правда, у него тоже, помню, работает. Виктор, у тебя тоже выпадает что-то, да? Да. Руки помощи.
Кто здесь сейчас?
Вот буквки мы.
I cannot open the DM, I don't know.
Метнуть.
Ну, попробуй.
Метнуть его.
У тебя открывается?
Да, у меня работает. Заранее спланировано.
Starting
Реклама, да?
Вы специально там договорились, подкинули баг?
Да.
Наш человек.
Закоритель. Подвиг.
Okay.
Ну да, и
Виктор, тебе дать ноутбук, где это работает? Может, поможет? А?
Okay.
Я просто.
Try that one, but
Мне жалко. Сейчас я
this
только
you should, I mean, this is what you test.
конфиденциальную информацию закрою.
What's going into this? Like it dead meat anyway. Okay, you try to
Пишут программу с нарушением лицензии.
Ну да.
Ah,
Тихо, я программирую по дороге.
let me do that. One second. Might be because of the projection. It worked before. I mean, it did
я
it.
даже не помню, да, это сок ставишь.
Okay.
Это
Now,
такой кошмар, в общем. Я там как-то нет, Саша сделал, и все.
okay, there you go. It worked. Changing the projection. Okay. So if you open this in here, in case it was installed, you have this extended toolbox, which is very similar to the list of the algorithms that we had in SAGA, right? We have the list of the modules, they were called modules in SAGA. They're called these algorithms in here. And you have this is the simplified interface, which basically has this group called geoalgorithms, and then it has all the geoalgorithms. But they're not only SAGA algorithms, they come from different places. Like, okay, you are familiar with a tool called GRASS, or then there's another thing called OTB for image analysis. But if you go to the advanced interface, then you have everything divided depending on the origin. And you can see that there's a group called SAGA, right? And you have every single thing that you have in SAGA, right? It's exactly the same thing, but in here. But the good thing is that you have other algorithms. You have here Orpheus toolbox, or we have probably have heard of this R, the R computer language. For statistics, you can call R from here, you can call GRASS, you can call many other things in here, right? This is not one of the most interesting things, but well, we have everything together. But the most interesting thing is that you don't just have the toolbox, but you just have other elements that you can use for being more productive. Like basically the modeler, which is what we are going to see today, right? So let's do something very simple, and let's go to SAGA, area analysis, Geomorphometry. Let's try this convergence index that I show you, right? So you see it's not exactly like in SAGA you have this table that is the same thing. You have parameters and values that you have to drive, right? And then you can take the value from here, from all the lists that are loaded in QGIS, select the method, etc. Right? It saves to a temporary file, just like SAGA does. Everything's temporary, right? Okay. So you get the idea, it's basically the same thing, right? So I'm calling SAGA, but instead of being inside of SAGA, I'm outside of SAGA. And I'm just calling there, but it's going to do exactly the same, right? Just run things, right? You see, there's a convergence index, right? So what I've done is just call SAGA, but instead of doing it from SAGA, I call it from outside, and I get basically the same result, right? So if you can do things in SAGA, you already know how to do things in SAGA, how to calculate this low, how to calculate the channel network, etc. You can also do it from QGIS, which is much more powerful than SAGA. You have all the power of QGIS plus all the power of SAGA, right? So I'm going to make a very small example to calculate the this topographical necessity. No, wait, I'm going to go straight to the big one. So I'm going to try to show you how to do this whole thing that we've done. Remember, we have made several steps, right? We started with the sink filling, then we did the catchment area, then with the catchment area we calculated the channel network, from the channel network we calculated the basin, and then we vectorized. So there's several different steps, right? So now imagine that you go back to SAGA, and it's like, instead of this elevation model, you have a different one. Right? So you have to calculate the watersheds from this one. You have to do everything back, all the steps. Right? You have to do the same filling, blah, 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 blah. So 6 or 7 steps, might be 50, it might be 100, right? So there should be a way to automate that. And how do we do that? We do that with something called a modular, right? So this is the most interesting thing here, is that I have all the algorithms in here, right? All the ones from SAGA plus other one. One good thing is that I can search. So if I don't know where the slope is, I just search and I find it there. It makes it much more easier, right? To use instead of just trying to find where it is, I just want the catchment area. I do that. Well, catchment area, right? And I don't have to know where it is. I can search. This is one small thing, but it makes it useful. But now, let's say we're going to try to do that whole process in one. This starting from the DM and ending up with a vector layer with bases. Right? How do we do that? We do that in this thing called a modeler. Right? What is the modeler? Well, basically, the modeler defines a workflow. It's a set of steps that I do using different algorithms. That might be SAGA algorithms, or it might be algorithms from my place. In this case, I'm going to use SAGA. So I have to define two things. First, the inputs that I want, as what do I need to do all the processing, and then which are the steps that I have to take in the processing. And you should already know that. We have started with a digital elevation model, right? So the only thing that I need, the only input, it's a digital elevation model. And then what have we done? We started with sink filling, catchment area, blah, 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 etc., etc. And this is the process, right? So this is what we're going to run here in these two parts that you see, inputs and algorithms. First, you define the inputs. Second, you define the workflow. Right, and this is what I'm going to do. The first thing is just to define the input of type raster layer. What's that? We're doing like programming, but graphical programming. Right? So this is DM. And it's required. Remember those things in SAGA with the 2 arrows or just one? In this case, that's that. And you see here, this is the shape of our model, which actually defines the workflow. Okay. So we started with the DM. What was the first thing that we had to do to get the watershed basins? The first thing was to do the sink filling. Okay, pre-processing. Okay, you just go in here, SAGA algorithms, blah 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 blah. Metrology. Move up the first thing. Right? And you see, instead of just being able to use some layer from the ones that I have loaded, I can just use the layers that are in the model, because there's like a conceptual model, right? I'm not going to run it, I'm just defining it. So I just can use this raster layer, which I have defined. Okay, so I use it, and then I'm going to generate a field DM, which is take enter name if this is a final result. It is not a final result. It's a temporary thing that I want to get before I get to the end. Okay, so right? So that's it. You see, it takes that, and it's going to generate the field DM. What is the next step? The catchment area, right? That's it. Catchment area parallel, right? Now I take the elevation, but I don't take the DM. I take the one that is generated by the other algorithm that I have added. Field DM. Right? And basically that's it. I'm going to use this method. This is the same things as in SAGA, and it's going to generate a lot of things that are not final. That's the second step, right? So I'm just going step by step. Then I'm going to use this catchment area right now to calculate the channel network. But I need a second value. I need one value that was, remember, we needed the threshold, right, to use. Okay, that was the value that defined where the rivers were starting, right? We were using 1 million, remember 10 million. That shouldn't be hard-coded. That should be a fixed value, right? We should give the user the chance to select one. So we're going to add a new input, actually, of type number. Here, right? So I'm going to add a new number, and it's going to be or threshold, right? value is 0, and yeah, I can use the default value. Right? So now I have another input that is alone. I'm not using it, but I'm going to use it now because I'm going to add a new algorithm, which is the channel network. I'm going to put it now.
Can you show the parameters?
Yeah, to edit anything, you just can double click on it. So I just take the field DM, right? So it's connected to this one. I have to take this, the field DM. The other ones that are not important. Ah, the threshold, okay. The threshold is just his name, and then mean value is 0. You don't even have need any value. So next step now is the after the catchment area, next step is the channel network, right? So I use the elevation, I don't use the DM, I use the field DM, right? Then the initiation grid is the grid that I'm going to use with the threshold, so that is the catchment area, actually, right? The initiation type is not less than, is greater than, and the threshold I can enter a fixed number, or I can use any of the ones that are going to be entered by the user. In this case, I just have one, which is the threshold, right? So I'm telling here in the model, I'm telling that use the threshold that the user is going to use. Right? And the other things you can do like that. So I'm just connecting pieces, right? What I'm doing is connecting the different pieces, algorithms and inputs, and create workflow, right? Okay. So you see, you can click on this plus and minus signs to see where everything is coming from, right? You see. So that's basically the puzzle, and I'm just linking pieces. After the channel network, I go to the watershed basins. Watershed basins, that's the next one. Elevation is the field DM, and the channel network is the channel network. Right. And I just stick the other ones like that. This is a little difficult to organize, clearly. Okay, something like that. You see that I'm using the field DM for many things, so maybe that's a clear way of putting things. Okay. And after the watershed basins, there's just one last step. I'm going to get the raster basins, and I have to vectorize them to get the vector watershed basins. So I just go to shape grid, and I just vectorize into the classes. And I vectorize the last layer, watershed basins, and it's all classes. Right? And this is something that I want to keep. All the other things that have been calculated, they were temporary. Things that I didn't want to keep. But I want to keep this one. Enter name, if this is the final result. This is the final result. This is what I want to have. Right? So this is watershed. I can add more things as I did, like calculating the area, etc., but I'm going to stop here. So I'm just finishing my workflow, and in the last step I'm going to actually produce something that I want to use to keep. Right? This is the actual result. So you see I'm starting with the DM, I calculate the field DM, which I use in different places, the catchment area, channel network. So it's a pretty logical thing, right? And now whenever I need to calculate these watersheds, I don't have to go step by step. I just do it everything one step at a time. Take this DM and get me the watersheds, right? So what I have to do is to enter a name here, model, right? And a group where I want it to be, and I have to save it. I have it already saved, so I'm not going to do it. But when you save it, so you just like, actually you can see it, there's an example model which is that one watershed and DM, which is exactly like that. So I wanted to show you how it is created, but it's basically like that. So I'm going to close that because you can save it, but it's already there. So actually it's in there. actually find it in models. It's one of the example models, and it's called watershed DM threshold. And I can open actually edit the model. You see it's the same thing that I've created. But I can execute it now like I did with the other. Just double click and execute it. And you see there's the DM, because I defined one input called DM, raster layer. Now I can select the raster layer. The threshold, because I defined an input of type threshold. And the watershed, because I defined that the last output was going to be called watershed, and it's the vector layer, right? So that's it. In one step, when I call this, it's going to do all those things that I have defined, right? It's going to take the DM, fill the sinks, calculate the channel network, calculate the catchment area. With that, it's going to calculate the channel network using that threshold, and then it's going to calculate the basins and vectorize. So I'm just putting 7 steps, 6 or 7 steps into just one step, right? So as you can see, this is pretty, that's a good thing for being more productive, I guess. Just run it, and you see it's running 5 algorithms actually. It's running catchment area, now it's running channel network, and it's doing all that. It's called in SAGA. You see all that text, it's called SAGA. It's doing it automatically, so you don't have to worry. It's doing all that, and you see, voila, that's it. Just one step. But what is the good thing about that? It's like, I think that this threshold was not a good one. Yeah, let's try with 1 0 left. And I don't have to do all the steps. I just do that, and it will do everything again, right? So I don't have to worry about that. Even if I want to change a single parameter, which is in the first step, then I have to redo everything. And here I don't have to do that, right? You see, I'll just change one thing, and in one go, I get it, right? So you see, I'm much, much more productive with that than with SAGA, right? I don't know if you get the idea. Simple, right? There are more things that I can do, because now imagine that I can be even more productive with it. Because imagine now that you have to do that thing. You have to calculate from a DM, right? And using that threshold, you have to calculate the watershed, but not for 1 layer, but for 100 layers. What can you do? Well, you can open them in here. You open your 100D television models. Let me get rid of that. So you open your 100, and then you can, okay, 1, and you run it. The other, and you run it. But no, there's not a tool in Sextante that allows us to do that even faster. You just right click in here and say, execute as a batch process. And then you just take here, you say, okay, let's go to data. Well, let's see. I'm not going to do it right now. This DM, and this other blob. And then you just can put things in there. And then you just select layer. For instance, watershed dot shapefile. And I say, yeah, go to outer field, value DM. So it automatically sets the name, which water DM25, water, takes that name and puts it there. So it's pretty easy to fill the table, no matter if it's 3 or 300. Then you just keep on running and it creates in rapid salvage now. So you see it's very productive to do that kind of thing, right? And what is the idea of that? The idea is that you should understand what things mean in SAGA, but then instead of running them in SAGA, you can run them from here. It's much more productive and much better, right? You can create your model, and also you can combine them with other things. If you're familiar with the R scripting, the R computer language, you can add your R scripts, and you can call R from here, right? And do other things. Let me show you something else. Well, let me go back to that. It's pretty useful now, in fact. Let me calculate that. Zeros are in there. That's because the number was too high. So, no, actually no, not the well, anyway, yeah, that's better. I'm going to show you another productivity tool, which is the iterative execution. That, let's see. Imagine that I have one of these polygons, and it's called So this clip graded with polygon is something that you've probably seen before. It's like I have my raster layer and I want to, like a cookie cutter, cut that just with the shape of the polygon, so I just get data inside of the layer, right? So I can do that with this DM and my basins. Just run that. And what I get is that actually. So it's a clip DM, right? Imagine that I want to calculate some statistics. So it makes sense to calculate them in here because that's the statistics of the basin. It's not just an arbitrary rectangle. So this is something that actually makes sense, right? But now imagine that I want to do that instead of for all of them, right? Instead of for all these polygons, just for one of them. Okay, which is the way of doing that with extended? Well, you can select that in QGIS. Just here, select a single feature. I can just select one. If I select something, then it's going to use only the selection, right? So I just go back, create grid, and it's going to click my grid. Just using that one, right? So you see, let's just click from that, right? Now imagine that instead of having, I don't know, 1, 2, 3, like 9, 10, I have 100 polygons. So I want to click that all those polygons one by one. So I have 100 layers, each one with the DM, within the basin, right? So how can I do that? Well, it's easy. Select, select, and run. Select, and run. So it's boring again. So I just go back to my clip grid with polygon. I'm going to remove the selection actually. Select feature for layers. I can get rid of that as well. So I go back to clip grid with polygon, and it's just like, okay, this is my DM. These are my polygons. But I click on this button here, iterate over this layer, and it's going to do the same algorithm, but just running one with the polygon, again with the other polygon, again with the other polygon, and instead of generating one layer, if there are 100 polygons, it's going to automatically generate 100 layers. So just click on that, just run. That's like 16 times. There it goes. Okay. I'm going to tell you how wide that happens. Doesn't expect. Okay. And I have all this. You see, it has failed, but it has generated everything, right? So then what's the problem? Because you complain. It said there were 16 basins, but actually you cannot count 16. The thing is that when I calculated the basin, I didn't set a minimum size. So there are some basins that just have one basin. So then they're very, very tiny, and when I try to click the grid with that tiny thing, it can't click it. So SAGA cannot do it. So that's the problem that we have. But you see, I have created all these new layers with that, and you can do anything that you want. You can create a model that, for instance, calculates some statistics, and then you say, okay, I want a statistic for this layer, but I want it for every single layer. So you can do that automatically. So once again, what's the good thing about this is that you have all the things you have in SAGA or in GRASS or other algorithms in there. You can automate things. Right? You can make things automatic. It's like run your batch process, create a model with a workflow, run iteratively. Also, if you are like a bit more, a bit of programming, you can go to the Python console and you can just run in here and import Sextante, and then you can run things from here, just like run in Sextante. Now. Weird for you. I don't know. So, I don't remember the name of this one. these are all the algorithms that I have for slope. So I have this one called SAGA absolute error. I can write that one, and I can write things from here. So you can make small programs with loops and conditionals and things like that to make it even more powerful, to just automate things. Right? So everything that you have in SAGA, you can run everything from here. And also the good thing is that whatever you generate, you have it here in QGIS, which is much more powerful for creating then if you want to create here composition, or you know, create a layout, just actually print them out. It's gonna look better. That's it. Right. All things that you can show you. Right. That's basically what I have. I don't know if you have any questions. We can just say, you know, I can just go and use other things, but I guess that should be everything. This one thing, yeah, I'm gonna finish with that. Actually. There are some algorithms in SAGA that actually you can use in given examples, not everything perfect. There are some algorithms that you can use, and these are the so-called interactive algorithms. And I'm going to show you one. Just see it. So I'm going to open back my. Oh, I don't have. I need to. I guess I have so. Don't forget. I'm going to open VM and I'm going to. It's actually. So I have my DM, right? And all the algorithms that we have run, we just went here and said, okay, click, enter the parameters, and the result was created. There's a different type of algorithms that you see, they're called interactive ones. You can follow me on that if you have yourself there. And one of these interactive algorithms, for instance, is one that instead of calculating that watershed with all those channels, you can actually point and click. It's like here. Here's the outlet. From up there, just create a place. And this is what I'm going to do now. Right. So I'm going to show it to you. Channels. So geography. Should be for absolute area, right? You know, there's absolute area and then absolute area interactive. Okay, what is that? You just fill your things in here, and when you click on OK, it's not going to do anything. Right? Because it's going to close the window and it's going to wait for you to click somewhere. Right? I'm not going to run it now because I want to select a place that is a very good one for calculating the watershed, and that means that I should select a place with a high flow accumulation. Okay, I'm going to tell you what I mean. If I just select this one, now I select the elevation in here. Okay, and now if I try to click in any point to calculate the absolute area, most of the times I'm not going to click in a point with a large absolute area. Sorry. Select here. You know, this is the absolute area from that point, right? And this is not that big. Select data. Just click in here. You know, it's hard to find a point. So what can I do? I can just stop this and calculate the catchment area actually. So I can find a point with a higher accumulation, right? So I just go in here, in the modules, catchment area, D8. So that will let me select better. That's it. Now show the catchment area. Okay, I zoom in here so I can find a place with a high accumulation, like this one, and now I go back and I run the absolute area. I select here D8, so it's the same method, and that's fine. And it waits for me to click in here, I click in here, And you see, this is much better. So this is the catchment area. From that point, that is the catchment area. And now I have this catchment area that I calculate. I can click on any point and automatically calculate all the area that flows into that. You see, this algorithm is interactive because if you just click on any other point, now select that and click on any other point, it changes, you see. But you cannot run that from QGIS because there's no way of interacting. SAGA doesn't allow to run those modes from a different software. You have to run them from within SAGA because, of course, it has to show something where you can click on, right? And well, I don't know if you have any other question. It's already 6 o'clock, so I don't know if you have any questions. Whatever, if not, just feel free. SAGA is free software. It's open source. You can download it, QGIS as well, Sextant as well. So you can just feel free to download it and use it. And, there's a SAGA mailing list, there's a QGIS mailing list. You can get in contact with me directly. You come in here and or whatever. And I don't know if you have any suggestion, question, or whatever. Yes.
Ни у кого нет вопросов никаких.
Не, я хотел спросить, а вот книжка, которая в PDF, ее можно распространить в интернете?
Well, not a lot, but yeah, you can give it to some people, but not just put it in.
Не, вообще она продается.
Well, maybe you can put it, you don't say that it was me who gave it to you. I mean, for me, I participate in the book, but the main author of the book, my book. But yeah, because it's
Ну, семинар.
probably. Now, don't put it on the internet like, okay, this is Geomorphometry book, don't buy it here. Just, yeah, you can press it.
Нам Виктор дал, мы напишем. Нам Виктор дал.
No, as long as you don't do that, then it's fine.
Мы можем.
Okay.